This is Algebra Radicals review. You're going to need a calculator as we go through this, so I have up the Desmos Scientific Calculator. The first thing you need to do is generate a perfect squares list. So you have a copy of this in the geometry notebook. You can make your own copy of it and type in these numbers, or you can write it down. So the numbers that I filled in have just been calculated. So like the 361 at 19 squared, I just went to the calculator and typed in 19 squared, and that's where I got the 361. So you should be able to very quickly type in these calculations and fill in the perfect squares. This is something that we're going to reference as we simplify radicals. So simplifying radicals, first thing we need to understand is what a radical is. So up here at the top of the page, we have radicals. So this symbol that we have is what we call our radical. So the radical is the symbol. I've run out of space there. So our radical is the symbol. The radicand is under the symbol, and the index is outside and to the left. One thing about the symbol is if there is none, then it's a 2, and that's our square root. So we're going to be working with simplifying radicals. So this first set of notes is all about simplifying, and there's two methods. And I personally prefer method 1. Method 1 uses the product property of radicals, which says that I can write any number as a multiplication problem, and then I take the square root of each piece of that multiplication problem. One thing about this is I actually don't like the example that they give, because 36 just so happens to be a perfect square. So if you look back at our perfect squares list, you'll see that 36 is a perfect square. It was calculated by doing 6 squared. So the answer to this one is just 6. But they do a little better of that in the examples. So these are non-perfect square numbers, and we're going to look at simplifying the radicals. So step 1 of our process is to find a perfect square factor. So with a perfect square factor, we're going to use that perfect squares list. So my number is 72. So I go over to my perfect squares list, and I'm going to start at 64 and work my way up the list until I find the perfect square factor. So 72 divided by 64 is a decimal. So I go to the next one. 72 divided by 49 is a decimal. 72 divided by 36 is a number. So this is the first time I got an integer number. So this is the set of numbers I'm going to use. I'm going to use 36 and 2. So when you look at this, the first radical is the perfect square, and the second radical is how many times it went into the original number. So once we have our perfect square, we evaluate the perfect square. So the square root of 36 is 6, and we keep the non-perfect square. So this non-perfect square portion we keep. So they did the same thing for the other one, 48. 16 was the perfect square that went into it, and it went into it 3 times, and the square root of 16 is 4, and they keep the square root of 3. So this is the method that I prefer. One thing that you do need to remember with this final method is to do any leftover multiplication. The other method is doing what they call a pair or tree method, and they actually have the notes for this particular method written out for you. So you're going to break it into prime numbers, and this is where you do the factor tree. 72 is 2 times 36, which is 2 times 18, which is 2 times 9, which is 2 times 3. And then all of these numbers are put underneath the radical. So it's still breaking it into a multiplication problem, but of all prime numbers. Once we have that, we group together pairs. So the pair of 2 and 2, and the pair of 3 and 3. And then we simplify those pairs. Now you can actually skip this step where you multiply and then break it back out, because the square root is anything that you multiply by itself to get that value. So we're doing 2 times 2 to get the 2. So the 2 times 2 gets us to 2. The square root of 3 times 3 is 3. And then we keep the square root of 2. One thing you do need to notice is in the example down here of 24, they paired the 2 times 2 and got the 2, but pay attention to what happened with the other set. 2 and 3 were not a pair, so this 2 times 3 became 6. So you actually have to remember to do any leftover multiplication there. So if you have a multiplication and it's not a match pair, you actually have to multiply. So don't forget to multiply. So just a few more example problems. So here's those same examples from the previous page. I'm not going to do any further examples of the prime factorizations. I want to do the one where we use this perfect squares list. So I'm going to work with the 40. So I need to use my perfect squares list and see if I can find the perfect square that goes into 40. So back to this list. Oh, shoot. Deleted some of that. So this is 1, 4, 9, 16, 25, 36, 49. Okay. So we're going to start with 36 because that's our first perfect square smaller than 40, and work our way up. So 40 divided by 36 is a decimal. 40 divided by 25 is a decimal. 40 divided by 16 is a decimal. 40 divided by 9 is a decimal. 40 divided by 4 is 10. So this is the set that I'm going to use. It's 4 times 10. So I'm going to use 4 and 10. So the square root of 4 times the square root of 10. We're going to simplify the square root of 4 You can do this from the list or calculating. The square root of 4 when we go back was 2 squared. So this one is 2. And we keep the square root of 10, and there's no further multiplication. So my next one is 63. And it turns out that the perfect square that goes into 63 is 9, and it goes into it 7 times. The square root of 9 is 3, and we keep the 7. Now, not every square root will simplify. So here's an example. This is 41. So when I start 41 divided by 36, I get a decimal. 41 divided by 25, I get a decimal. 41 divided by 16 is a decimal. 41 divided by 9 is a decimal. 41 divided by 4 is a decimal. And the only perfect square left is 1. But if I do 41 times 1, I just get right back to the square root of 41. So this one is already simplified. The next thing we're going to look at is the multiplication property. So we're going to look at a couple of different things. So multiplication, if you have two radicals in a multiplication problem, you can write a single radical and multiply the number values together. So the square root of 2 times the square root of 5 is the square root of 10. If you happen to have a coefficient in front of your radical, you multiply those coefficient numbers together, and under the radical, you multiply the radicands together. So coefficient times coefficient, so 3 times 4 is 12. Radicand times radicand, 2 times 5 to get 10. So step 1 is to multiply the coefficients. Step 2 is to multiply the radicands. And step 3 says to rearrange. So you would actually make sure that you put the answer to the coefficients in front of the answer to the radicands. The next thing is squaring radicals. So squaring means you're multiplying it by itself. So square root of 3 squared is the square root of 3 times the square root of 3. You multiply and simplify. Same thing with the 7 square root of 2 squared. So you do the 7 square root of 2 times 7 square root of 2. You have your 7s. You have your square root of 2s. Your 7 squared is 49. Your square root of 2 squared is 2. And then you multiply at the end. You also need to be careful to make sure that after the multiplying, you check to see if you need to reduce the radicals. So when you're looking at this problem, this first part is the multiply, and the second part is the simplify. So just because we're in a new set of calculations does not mean you get to forget about simplifying. So after we multiply, we do need to check to see if we can simplify. So we're going to look at some examples. The first set, these are just multiply. And the second set down here, we're going to have to make sure that we simplify. So in this top part, we're going to do our square root. 7 times 6 is 42. In the next one, we have this 3, so we just keep it. It's the only coefficient. And then under the radical, we're going to do the 2 times 5 to get 10. In the next problem, we have the 5 times 2, which is a 10. And then we have our radicals. So we're going to do our multiplication with the radicals, 5 times 3, to get the square root of 15. Now, none of those will simplify. when we're squaring, it just so happens that the square root and the square cancel each other out. So we end up with just the 5. So this is the square root of 5 times the square root of 5 to get the square root of 25. And they cancel out and we're just left with 5. In the other one, we're going to do 2 square root of 7 times 2 square root of 7. 2 times 2 is 4. The square root of 7 times the square root of 7 is 7. And then you're going to multiply these together to get 28. The next ones we have to remember to simplify after we multiply. So we're going to do our multiplication. So 3 times 21 is 63. As we saw in the previous examples, this is the square root of 9 times the square root of 7 to get 3 square root of 7. In the next one, we're going to do 2. We have the square root of 10 times 3, which is 300. And then we need to simplify. The perfect square that goes into 300 is 100. It goes into it 3 times. So this is 2. The square root of 100 is 10. We keep the square root of 3. And 2 times 10 is 20. And we keep the square root of 3. So we multiply, and then we have to simplify. The last thing we have here are radicals with division. If you have the square root of a fraction, we simply take the square root of each piece of the fraction. So anytime you're doing the square root of a fraction, you do the square root of each piece of the fraction. So once again, you're going to follow the process. So we separate and then we simplify. So once you separate it, then you simplify. Rationalizing the denominator. In math, we do not like to keep the radicals in the denominator. So in this particular process, we multiply both parts of our division problem by the radical in the denominator. So we are going to rationalize. So the radical that's in the denominator, we multiply by both parts of the fraction. After we rationalize, we multiply. So 3 square root of 2 and the square root of 2 times the square root of 2 is 4. And then we simplify. So we rationalize by multiplying by the radical in the denominator. Then we multiply. And then we simplify. So we're going to separate and do the square root of 9 and do the square root of 25. And then we're going to simplify those. So square root of 9 is 3, square root of 25 is 5. So we're going to separate. So we're going to do the square root of 20 over the square root of 4. And then we're going to start to simplify. 4 is the perfect square that goes into 20, and it goes into it 5 times. And the square root of 4 cancels out in both places, and we're left with the square root of 5. You may also notice that 20 divided by 4 also happens to be 5. In the next set of problems, we're going to start out with our rationalize. So we multiply both pieces by the radical that is in the denominator. Then we multiply, so 4 square root of 5 times the square root of 25. And then we're going to simplify. So this is 4 square root of 5 over 5. So we rationalize, multiply both parts by the radical in the denominator. We multiply. So 5 times 3 is 15. 3 times 3 is 9. And then we simplify. Square root of 15 is simplified, and the square root of 9 is 3. So rationalize, multiply only by the radical in the denominator. Multiply. So 4 times 3 gives me a square root of 12. I still have the 5. And 3 times 3 gives me the square root of 9. And now I simplify. Perfect square that goes into 12 is 4, and it goes into it 3 times. And in the denominator, the square root of 9 is 3, and the square root of 4 is 2, and 5 times 3 is 15. So make sure you're using your calculator wisely as you go through these options. You may need to watch the examples a couple of times to make sure that you're doing things correctly.